Hi folks, so in this video we're going to talk about how we can divide polynomials. And again, this should make sense or should be possible because, well, if you can add polynomials, you can subtract them. And so addition and subtraction usually come together. And multiplying polynomials is something we've done before, but we've never really talked about dividing them until today. So let's talk about how to do that. To be able to do this, we're going to use long division just like you did in grade school. So let's actually remind ourselves just how that works because it's probably been a while. So I'm going to say, let's do 8 divided by 576. Okay, so if I remember correctly, well, this is actually the hardest part. I think this thing is called a dividend. The thing you're dividing it by is the divisor. These are the ones I always get mixed up. The final answer, though, that I always remember for some reason, it's called the quotient. Okay. So the thing that we ask is, well, I fill them in kind of left to right, and I ask myself, well, how many times is applied, how many integer times, how many times does 8 go into 5? And again, you just use an integer amount of times if possible, or how close can you get, basically. Similarly, you could say 8 times what gets you to 5, and again, this number has to be an integer, and you want to get as close as possible. Unfortunately, it doesn't, right? 8's way too big, and so it doesn't go in at all, so we'll plug in 0. Okay, so now we go on to the next digit, and we say 57. So if I wanted to, by the way, I could go into 8 times 0 is 0, drop it down, and so on, but we won't do that. Okay, so I repeat the question. How many times does 8 go into 57? I'll just repeat that. 8 go into 57. Well, let's see. If I do 8 times 8, that's going to be 64, which is too big. But I think if I take away 8 from that, so I do 8 times 7, it'll give me to 56, which will work. Right? It'll be a little bit left over, but that's okay. That's as close as we can get. So I'm going to put 7 right there. Okay, so now I do 56 because that, again, that is 8 times 7. And then we subtract to see how much is left over. And so if I have 57, sorry, I'm trying to get to 57 and I fill it up with 56, I have 1 left over. Okay, that's fine. And I'll drop down to 6. Again, that's kind of just how we do things. Okay, last part. How many times does 8 go into 16? Okie dokie, sorry about that. So we drop down to 6 to make 16 now. And so last part, how many times does 8 go into 16? Well, that one's nice and works out perfectly. If I fill it with 2, then I have, again, 8 times 2 is 16, and we'll get 0 here. Okay, so again, that would be the remainder. If there was anything left, that would be our remainder, but in this case, we have a remainder of 0. And so this is why we say 576 over 8 is equal to 72. Okay, what does this look like then when we're doing it with polynomials? Well, let's take a look at an example. Okie dokie, so here's the example we'll work on. It's going to be 2x squared plus 11x plus 15. We're going to divide that quadratic trinomial by x plus 3. Okay. Now, by the way, there's a very fast way to do this without actually going to the long division, but this is just an example and a proof of concept to see how to actually do this. Okay, so just like before, we figured out, or we asked ourselves, how many times does 8 go into 5? And by the way, the process is not going to be exactly the same. It's going to be slightly different, but we should hopefully see the similarities and the parallels between the two methods. How many times does 8 go into 15, or go into 5? And so our similar question is going to be, let's go over here. How many times does x go into, so x being the leading coefficient of our divisor here, or sorry, the leading term, go into, well, the first thing that goes in the dividend is 2x squared, just like before. The first digit was a 5. Go into 2x squared. Now it sounds kind of awkward when we write it, like when we ask it like that, but if we think back to the way we drew out the equation that this question is actually asking, it's really just saying x times what gets me to 2x squared. Okay, that's actually not so bad because we know that is going to have to be 2x. X times 2x gets us 2x squared. So I'm going to put that in actually. Now this is where it gets a little bit different. I'm actually going to put it right here. And the reason I'm just doing this is to line up my term. So you see the 2x lines up on top of the 11x term. Why is that? It just helps me stay organized. Okay, so now we multiply, just like previously, we multiply that entry, whatever we put in the quotient, by the divisor. And so I'm going to do that. So I'll have 2x times x is 2x squared. 2x times 3, that's going to be 6x. Right, so that's all that is. That is x plus 3 times 2x. Next step, well, before we subtracted, so we're going to subtract here. This is the part that you want to be careful on. I try to always put parentheses here so I don't mess this up. Remember, you're subtracting. The reason this might be confusing is if this was 2x squared minus 6x, and then you accidentally, you subtracted, but if you're subtracting a negative, it should actually be plus. So just put parentheses here so you don't forget. These 2x squareds will undo each other. So we'll be left with 0x squareds. Don't need to worry about that. 11x minus 6x, that's going to leave us with 5x. And then plus 15. We'll drop this down. Don't forget that part. Same question now. How many times does x go into 5x? Well, I think if I have x times what it's going to get me to 5x, I just need to multiply by 5. So I'll multiply by 5, and I'll get 5x plus 15, which is nice because it's going to work. Everything's going to work out nice and with no remainders for us. And we're going to get, well, 0x and 0. So we're just left with 0, and we're done. So we just said that 2x squared plus 11x plus 15, divided by x plus 3 is equal to 2x plus 5. Before, if I had just erased this and left you with this problem, how would you have answered it? I don't know if we would have really been able to do it on its own. But if I rewrite it like this, now you will actually see that it's actually something you've been able to do the whole time. I'm going to take both sides and multiply it by x plus 3. So I'm going to go times x plus 3 times x plus 3 on both sides, and we're just going to see, oh, well, these will cancel out, and you're left with 2x squared plus 11x plus 15 is equal to 2x plus 5 over x plus 3. You just factored it, basically. And so that's what long division helps us do. Long division is a tool to help us factor bigger polynomials that we maybe couldn't quite factor. Now, again, this one was a quadratic. Sorry, that's a 15. Right, this one was a quadratic, which was factorable, and well, we know how to factor quadratics, but we could use this method to factor cubics, quartics, fifth degree polynomials, and so on. So the principle will still the same there. I'm going to work through another example in the next video where we will have a remainder, and we're going to see what that looks like. And then in the video after that, we're going to talk about how we can do this actually using the generic rectangle or the boxes if you use those to multiply. All right, so hopefully this helped clear things up, and I'll see you in the next video. Thanks for watching. Stay spicy.